In this last lesson, we're going to look at word problems with quadratics. We're going to mix them all together now. So we're going to have ones where we have to find a vertex. In other words, we're going to optimize something. Generally, we'll use negative b over 2a and plug it back in. Though if we have our zeros, we can always average them. Then plug that back in. If not, if we want to look for a solution, we know an answer we need to get. We're either going to have to use the quadratic formula or we're going to be factoring. So your big key today is to figure out, are you looking to optimize? So you're looking for some keyword, right? Min, max, highest, lowest. Or have they given you a value to solve for? Okay, so no new math, just a mixture of the things you've been doing throughout the course, kind of put into one lesson. Now let's take a look at some examples. The sum of two numbers is 49. Their product is a maximum. Oh, there's my word. I'm looking for a vertex. Okay. What is the product and what are the numbers? I want to do that. We're going to name ourselves an equation. They didn't give us one. We got to make one. So that's that x equal the first number. Well, if I make y be the second number, I know together they have to add up to 49. So x plus y is 49. Or in other words, y is 49 minus x. It's much easier to work with one variable than it is with two. So let's use my two variables as x and, if you would, 49 minus x. That's my second number. Okay, what do I know about these two things? I know their product is a maximum. So how do I find product? Product means multiply, which means my first number times my second number. So here's where to think about x times y, except for we know that y is actually 49 minus x. Well, if I replace it and then expand my brackets, I get myself a quadratic. If I put in the right order, I've got a nice equation for the product of two numbers based on this. What were we looking for? We're looking for a maximum. We know maximums happen at the vertex. To find the vertex, we need an axis of symmetry. So our axis of symmetry is x equals negative b over 2 times a. In other words, negative 4 over negative 2, or 24.5. That's my first number. My second number we said was 49 minus x. Well, 49 minus 24.5, also 24.5. The third thing we asked for was our product. We said our product was x times y, or in other words, 24.5 times 24.5, which gives us a total of 600.25. And there's all the parts and pieces we need. There's a maximum product of 600.25, and that occurred when x equals 24.5 and y equals 24.5. And we solved our first one. Some keys to point out to you. Try to work with one variable if you can. We knew a relationship. We knew they added up to 49, but it made it easier to talk about them both in terms of one variable, just the x. So that allowed us to replace in product. Again, we were asked about a keyword, a maximum. That tells us to use axis of symmetry and plug it back in. Let's try another one. The sum of the squares of two consecutive odd negative integers is 2050. Oh, they're telling us what the answer is. They're giving us an equals. This is a solving question. I didn't see the word min, max anywhere in there. I was told a number I have to get. That means I need to solve for it. But again, we weren't given an equation, so we need to set this up. What do we know? Well, we know the first number is x. We'll call it the first odd negative integer. How do I get the next odd negative integer? Well, to get there, I have to add 2. So for example, if I had the negative 5 as my first number, I add 2 to that, I get negative 3. That would be the next consecutive odd integer. Okay, what do I know about these things? I know that when I sum, I add up their squares. So I'm going to square them and then sum them. So I squared them, and then this is my sum, right? Add them together. And I know when I do that, it comes out to 2050. So this is a solving question. In order to solve quadratics, they have to be equal to 0 in standard form. So I need to get rid of my brackets first. I'm going to see a bracket squared. I write it out twice. I also want to make it equal to 0, so I'm going to bring the 2050 over to the left. Let's do some FOIL. X times x is x squared plus 2x plus 2x plus 4 minus 2050 equals 0. If we collect our like terms, we got 2x squareds plus 4x's minus 2046 is 0. I did that so I can get in standard form equal to 0. It's ready to be solved. How do I solve this? Well, let's make it simpler first. Let's try common factoring. And then we'll try some man. I need things that multiply to negative 1023 and add to 2. And now I got some cheating ways of doing this because I know they're odd and I know they're integers. I also know that they're 2 digits apart. So I'll try some things. 15 and 17. 17 and 19. 17 and 19. 19 and 21. They're not quite big enough. So if I keep trying, turns out that 33 and negative 31 are my integers. So I can write them in as x plus 33, x minus 31 is 0. Now my zeros, my solutions, are negative 33 and positive 31. But the question said that they're odd negative integers. So this number is inadmissible. That's a positive answer. It says they're negative. So x must be negative 33, and x plus 2 must be negative 31. So the integers are negative 33 and negative 31. Okay, so that was a solving question. Kind of one we've done before, but good practice. Let's take a look at the next one. A rectangle, 3 meters longer than it is wide. Okay, well, I can draw a picture for that. Got a rectangle, 3 meters longer than its width. So the width is x. This would be x plus 3. Its diagonal is 15 meters long. Okay, they're giving me a number. They're telling me it equals 15. That means I should be able to solve this. So what do I know about rectangles? I know they have right angles in them. If they have right angles, and it's a triangle actually, I should be able to think about the idea of Pythagoras. A squared plus b squared is c squared, where a, b, and c are given. So we can write this out as an equation. I know what it has to equal. It means I'm solving. Right? To solve things, equal to 0, standard form. So I'll write my bracket out twice. Let's bring that 15 over to the left-hand side so it equals 0. We'll FOIL. 15 squared is 225. We'll figure out that number. Then we can collect. And now I've got an equation that's ready to be solved. How do we solve it? Let's make it easier first. Let's common factor. Let's try some man. Multiply to negative 108. Add to 3. Are there any numbers that do that? 3 digits apart. Well, if I try 12 and 9, that seems to come out to 3 if I make it a negative 9. So, x plus 12, x minus 9 equals 0. My zeros are negative 12 and positive 9. But I can't have negative lengths. That's inadmissible. So, how big is this rectangle? The rectangle is, well, it's 9 for sure, by, how big was the other side? When x is 9, well, then this is 9 plus 3, so it's 12. It's 9 by 12, and we solved it. Again, it's a solving question because they told me something. They told me the number it has to come out to. They told me the diagonal was 15. All right, try another one. Another rectangular field. To be fenced along the four sides with two more fences parallel to the shorter side, dividing the field in thirds. Okay, let's think about this. Rectangle. Two more fences parallel to the shorter side, so in the same direction. So I'm going to divide into thirds. There we go. 800 meters of fencing are available. So if I go all the way around the outside, ends through the middle, I got 800. In other words, I've got a perimeter. The perimeter is made up of 1, 2, 3, 4 of these, and it's made up of 2 of these. So I can say my perimeter is made up of 4 x's and 2 y's, and I know that comes out to 800. Ooh, I got 2 variables. I don't like 2 variables. Let's make that into another variable. Let's get y by itself. Okay, so bring the x over, and then we'll divide everything by 2. So 400 minus 2x is y. I like only work with one variable if I can. What do we need now? What dimensions of the field give the maximum area? Area. How do I find the area of a rectangle? Area is length times width. Well, my length is x and my width is y. But I know that y can also be called this stuff. So in other words, I have an equation that only has an x in it. I can simplify that by expanding and rearranging. And really, the area of this rectangle is given by this. Well, good. I find the area. All right, what does it want? Maximum area. Oh, is that key word again? Axis is symmetry, vertex, all that good stuff. So my axis is symmetry. X equals negative b, negative 400 over 2 a's, negative 2's. So it's negative 400 over negative 4, which is 100. There's x. How do I get y? Well, we said earlier, just a second ago, that y was 400 minus 2x. So 400 minus 2x. And we know x, we just figured it out. It was 100. Oh, that gives me 200. How do I find the area of a rectangle? Isn't it length times width? 100 times 200. That's 20,000. Oh, that's all I need. The max area of 20,000, and it was in meters. When did we get that? We got that when x was 100 and y was 200. That wasn't too bad. In fact, if you go back and look at it, that question is just like the first one. There we were dealing with numbers. Here we're dealing with perimeter and area, but the same idea. All right, last one. Finish it off on a good old money problem. Studies have shown 500 people attend a basketball game and the admission price is $2. Okay, so revenue. We know it's 500 people, $2. Number, price. We're going to change it, right? For every 20-cent increase, it goes up 20 cents. Every time I change the price, number of changes, what happens to our people? Ooh, they drop by 20. That's reasonable. What price will maximize profits? Ooh, maximum. Maximums, I need the vertex. Find my vertex. It could be over 2a. It's handy, but I need to put this in the right order first. So 1,000 plus 100x minus 40x minus 4x squared. Okay, did I put a FOIL? Put in the right order. Negative 4x squared plus 60x plus 1,000. Okay, I did this to find my axis. So my axis of symmetry, x equals negative b over 2a, negative 60 over negative 8, comes out to 7.5. Okay, that's how many times I should change my price. So I got to plug that back in. What am I asked to find? What price? What revenue? Okay, so my revenue equals, we started at 500. And we're losing 20 people every time we change the price. We change the price 7.5 times. We started at $2 and we increased the price by 20 cents 7.5 times. So what do we get for numbers here? 350 on this side and 3.5 on this side, which when we multiply them together gives us 1225. Okay, max revenue of 1225 when what are we going to charge? What was our price or number? Started at 500, ended at 350. Started at $2, ended at 350. So we should charge 350. That was all part A. Part B, to break even, the organizers need to bring in $12.50. What price should we charge to break even? $12.50 just to break even. Except we just figured out they have a maximum revenue of $12.25. So is it possible to bring in $12.50? I don't think so. So they can't break even. Since the max revenue is $12.25, it is not possible to bring in the $12.50 required to break even. They can't even break even. They're losing money no matter what. Okay. And that takes us to the last example. Okay, so a bunch of practice. There's an assignment on the website. Print that off. Try some questions. There's a few there you can try. And we've got 8. Just good practice spending some time on these. And the more you do them, the easier they get.